So more modern research and theories recognize that short-term memory is more than just a temporary holding space for information that is within short-term memory. So within the short-term memory, we can manipulate information. That's what allows you to read the sentences on this slide. In recognition of this ability to process and manipulate information, short-term memory is now referred to as working memory. Baddeley, in his conceptualization of working memory, identified three distinct subcomponents and functions. So these are the phonological loop, the Visuospatial Sketchpad, and the central executive. So we'll examine each of these. First, the phonological loop is the verbal auditory storage space of working memory. We've talked about maintenance rehearsal. Most people rely on their phonological loop for this. We repeat the information over and over again in our mind. What's fascinating is that even though we're not saying it out loud, the same auditory processing centers of our brain are active as though we were. So it's like we're producing and hearing an internal voice. This is sometimes called our inner voice or engaging in sub-vocalizations. So the idea is that if you are given this list, 5, 6, 2, 8, 1, 7, 3, that you would repeat those over and over again in much the same way as though you are saying them verbally out loud. We know that people are engaging in this sub-vocalization and that these sub-vocalizations are processed similar to actual speech because research has demonstrated a speech rate and a word length effect in working memory performance. If two people have normal intelligence but different rates of speech, then the person who talks faster will typically perform better on a working memory test. So I thought of Robin Williams and Matthew McConaughey as our celebrity examples. But if you have any other celebrity examples of people who talk really fast or really slow, let me know. We also see the word length effect, in which it is more difficult to memorize a list of long words compared to a list of short words. And so this is one reason why typical working memory span tests involve digits or letters rather than words. Further evidence that the same areas of the brain are involved in both auditory processing and subvocalizations comes from sound-alike mistakes. For instance, if a participant is asked to memorize the following sequence, A, Q, T, E, I, M, P, then if they make a mistake for this letter E, they are more likely to mistakenly recall a V rather than an F. So the mistake is the letter that sounds like E rather than the one that looks like E. So again, suggesting that we're engaging in the subvocalization and using this inner speech. If participants are asked to memorize a list of letters and simultaneously say out loud, ta, 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 it disrupts their later recall performance. They couldn't rehearse the letters and repeat ta, ta, ta out loud simultaneously. What's fascinating is that the same type of interference occurs for individuals who speak American Sign Language if they are asked to move their hands while they are engaging in this memorization task. So the same area of the brain that controls hand signing is involved in internal rehearsal for individuals who speak American Sign Language. If we look at the Visuospatial Sketchpad, it works in much the same way. So we are engaging in maintenance rehearsal with the Visuospatial Sketchpad, except that it holds visual and spatial information. And so you can try out the test of the visuospatial working memory in your chapter. So I had quite a bit of trouble with this because I'm not good at spatial visualization or kind of mental spatial tasks. We can also test the capacity of the Visuospatial Sketchpad by presenting pictures instead of a word list to memorize. Also read in your book about the test of visuospatial working memory in non-human primates. If we look at the areas of the brain that are involved in working memory tasks, we see that areas of the cortex that are involved in auditory processing in the left hemisphere seem to play a role in the functioning of your phonological loop, right? In maintenance rehearsal for verbal information. If we look at your visuospatial sketchpad, we see that this is associated with activity in your right hemisphere that is processing, rehearsing, and maintaining this visual information. We can also look at other areas of the brain that play a role in monitoring information. And so this seems to be part of your frontal lobe, particularly your prefrontal cortex, that plays a role in monitoring information. And so working memory monitoring of visual information involves primarily the right ventrolateral prefrontal cortex, whereas monitoring of verbal information involves both the right and the left ventrolateral prefrontal cortex activation. And so again, we see this distinction between the phonological loop and the visuospatial sketchpad in terms of the areas of the brain that are activated when rehearsing verbal versus visual information. So the dorsolateral prefrontal cortex seems to be involved in the functioning of the central executive. So this last system of Baddeley's model. So we have been talking about the phonological loop and the visuospatial sketchpad, and particularly kind of focusing on this maintenance rehearsal of information within working memory. This seems to involve the ventrolateral prefrontal cortex. We look at the dorsolateral prefrontal cortex. We're looking at functioning in the central executive. The central executive is almost like the boss, the supervisor of working memory. And so the central executive plays a variety of roles in terms of updating and manipulating information that is within your phonological loop or your visuospatial sketchpad. So updating and monitoring information that is in working memory. The central executive also plays a role in goal setting and planning the execution of tasks. It's involved in task switching. So it's playing a role anytime you engage in multitasking, for instance, and you have to switch between various tasks that you are attempting to accomplish within a short period of time. And it also plays a role in directing and maintaining attention and response inhibition. So, for instance, controlling impulses. So we can look at each of these functions. When we look at the first, so this idea of monitoring and updating information within working memory. We can see this play out in tasks such as this. So in this particular task, you have 6 pictures. With each trial, you are asked to select a different picture, so one that you have not selected on a previous trial before. And with each trial, the position of all of these pictures will be shuffled. so that you can't simply start here on the top left and kind of work your way across. That won't be an effective strategy. You have to remember, if you select the squirrel, you have to remember that you select the squirrel because the position of the squirrel will change in the next trial or here in the next slide. And so you go through, and there's 6 pictures. In 6 trials, you need to select a different picture each time, right? So that by the 6th, you have selected all of these pictures just once. And so this is a self-ordered memory task. It can be studied in humans and in primates to see the role of the central executive here in updating and monitoring the information that is stored within working memory. To direct this task. So I need to remember, I have picked the squirrel, the tree, the strawberry. Now I need to pick maybe the car. For our primates, here we can have a series of containers that each contain a treat. And on each subsequent trial, they need to remember which container they've already gotten a treat out of. Because if they reach in that one, it'll be empty and they don't get a treat. So here on the first trial, our monkey picks the red container, gets the treat out and eats it. Then we mask the containers from view, right? So we screen and shuffle the containers. And our monkey gets trial 2. It needs to remember, even though the red is in a different position, it's already reached into the red container, it needs to pick a different one this time. So we see it picks the blue, and then finally our last container to get all of the treats. And so that requires updating information. Our monkey has to remember which ones it has already selected. And with each trial, it has to add information to that list. So initially it says, okay, I picked red. Then it has to add blue to that list so that finally in the 3rd trial, it has red and blue as previously chosen so that it can guide behavior and choose the new container that contains a treat. If we look at the central executive in terms of goal planning, then we can see this in a variety of tasks that we engage in on a daily basis. So your book talks about the Tower of Hanoi as an example of the need to plan and strategize, but of course, almost all types of games involve some degree of planning and strategizing, and our behaviors in just our day-to-day lives involve a great deal of planning for proper behavioral execution. If you have maybe wondered why you feel a little bit more overwhelmed, particularly if you are having some cognitive difficulties in terms of concentration, etc., part of the problem could be that we are, during these very chaotic times of the pandemic, overtaxing our central executive, that even the most kind of mundane daily tasks now involve a great deal of planning that is drawing on the resources of our central executive. So something as simple as getting a needed item from the store, doing your weekly grocery shopping if you need to pick up a prescription. For all of you guys who are thinking about how to get all of your work accomplished now that you're in online classes, you have to plan and strategize all of that, right? And that's drawing on those resources of your central executive. And maybe now this combination, right, of all of these things that need to be planned and organized is leading to kind of that feeling of being overwhelmed, right? And difficulties in concentration. If we look at the role of your prefrontal cortex in goal planning, we see this shift from the very front regions of your prefrontal cortex. So if we look at anterior to posterior, central nervous system functioning. So anterior, kind of closer to your forehead, right? Posterior, kind of closer to the occipital lobe, right, that we talked about. So if we look at just the prefrontal cortex, right, we look at the more anterior regions of the prefrontal cortex, we see that activity in that region seems to correspond to planning at a more abstract level, and that planning becomes more concrete as we move towards the posterior of the prefrontal cortex. Other functions of the central executive involve task switching. So switching between different tasks and updating rules for a particular task. We see this in what's called the Wisconsin card sorting test. So it looks something like this here. If you are given a deck of cards that vary in terms of the shape that is presented, the color of the shape, and the number of shapes on the card. So you see here that we have circles, stars, squares, plus signs. We have red, green, blue, yellow, and we have 1, 2, 3, or 4 shapes. So you start out, and the task is to figure out what the rule is for sorting the cards. So here you see that the starter card is 2 red plus signs. So maybe you think, well, maybe the rule is red, right? And you need to sort all the reds together, all the blues, so on and so forth. And you'll get feedback. If you put this 1 that has a red circle, you'll be told whether that is the correct placement or not. So if you're told no, then you can say, okay, well, it's not based on color. Maybe it is based on numbers. And so instead, the correct card would have been 2. And so through trial and error, you figure out what the sorting rule is, right? When you get that correct response, like, yes, you did it right. Now, what happens is that once you figure out the rule, right, things are pretty easy. But after a series of trials, they will change the rules. And so now you have been sorting fine, correct, correct, correct. Now all of a sudden it's incorrect because you need to switch what you're doing. Now, sorting based on number is no longer the correct response, and you have to figure out what the new rule is. Now, for most individuals, this is pretty easy to do and to accomplish. But those who have difficulties with functioning of their central executive, potentially damage or lesions to the prefrontal cortex, may have difficulty in completing this Wisconsin card sort task. The final role of the central executive is directing attention and response inhibition. So, can someone control their kind of automatic impulses in order to engage in goal-directed behavior? So this is sometimes tested through what's called the Stroop test. So if you haven't heard about this in previous classes, read in your book about the Stroop test and how it demonstrates this response inhibition or this kind of cognitive control function of the central executive. We can also see here individuals who, through potentially damage to their prefrontal cortex, may experience deficits in executive functioning. So here the task was to recreate the image on the left, so the image A, to draw it. And we see here that the person who did the drawing C on the right had some difficulty with controlling impulses, so their impulse to engage in creative artwork when that was not the task at hand, that was not the appropriate goal. If you remember Phineas Gage from maybe your intro to psychology class, or we talked about this a little bit in chapter 2, you know that he had damage to his frontal lobes, particularly his prefrontal cortex, and that after this particular injury and this damage, that many of his friends, family, co-workers reported that he had a variety of disruptions in executive functioning. So executive functioning is sometimes what we refer to this constellation of functions and tasks that are carried out by the central executive in the prefrontal cortex. And so he had a variety of difficulties that involved impulse control, right? So response inhibition, that people reported that he engaged in compulsive behaviors like gambling, or that he would lash out very violently and in anger instead of controlling those violent urges. That before he had been reliable and dependable, but after he had difficulty in kind of planning behaviors, right, and ensuring that he engaged in goal-directed behavior through that planning and organization, experienced difficulty with that as well. And so individuals who experience damage to their frontal lobes, particularly their prefrontal cortex, may have a variety of disruptions in executive functioning. So this is sometimes called dysexecutive syndrome. And your book has a few examples of individuals who have experienced such damage and the resulting deficits or disruptions that they experienced in things like goal planning and response inhibition, and even in terms of updating information in working memory. Okay, so individuals with frontal cortex damage may have decreased digit span, right? They may have difficulty completing some of these short-term and working memory span tests that we've been talking about. All right, so read more in your book about dysexecutive syndrome and more about the different areas of the brain that are involved in working memory tasks.